Looking at the Plant Cell by Jasmine Harris.
Children, quiet down. I'm taking roll. Okay, so Ashley, Celia, Chondria. Where are the Central twins? Ah, there you are.
Of course they're here. You can't miss them. They take up this whole room.
Celia, now you know that wasn't needed. I would gladly call your mother if that's what you would like. No, ma'am. That's what I thought. Okay. Well, it looks like we're all here. Great. Okay. First off, to let y'all know, my name is Organelli Andriana Cytoplasm, and I will be your tour guide today. Although many just call me Tour Lady, or Ugly Tour Lady, or better. But I personally would like to be addressed as Tour Lady. Okay, so today we will be taking a grand tour through a nice little plant cell. Yay! Aren't you guys just ecstatic? I know I am. Any questions before we begin our tour? Wait, hold that thought. Okay, now let it flow. Why is this called a song about cells? Why is your name Chondria? It's my name. Exactly. And that's why this is called Sing a Song About Cells. Okay, no more questions. I'll ask you to please step inside of the train in a calm and orderly fashion. Also make sure all hands, legs, arms, and feet are inside the car at all times. If you so desire to stick a hand out, you will never get it back. Really, there was a kid who stuck his head out. He didn't get it back. Now, moving on. We are here today to learn about the cell organelles. They're quite fascinating, you know. We're going to start out with the cell wall. Now, only plant cells have cell walls. Is that it? Why, of course not. The cell wall also supports the cell while allowing them to interact with their surroundings. Any questions? Good. Now on to the membrane. It's insane in the membrane. Insane. What does the membrane do? Well, I don't know. If you'd let me finish, I could tell you. Anyway, moving into the cell membrane, as you can see, that cute little blue thing at the top is the glycoprotein. And next we have our integral protein, which is the pink thing that looks like a tongue. Oh my gosh, those things are so cool, you don't even know. Anyway, you have your hydrophilic heads and your hydrophobic tails. They're pretty fascinating, don't you think? Not only that, but it's a lipid bilayer. Pretty cool. Don't you just love the cell membrane? I mean, come on now, who doesn't? Going in, into the cytoplasm. That is what is next after the membrane. Okay, children. The cytoplasm contains many of the other important structures in a cell. Like what? Well, the nucleus first off, right in front of you. Do you see the nice view? Yes, well that big thing is the brains of the cell. This contains the cell's genetic material and controls the cell's activity. Much like the brains that some of us use anyway. Don't really know about you kids, because you never mind. Now, moving on to the chromatin. As we move through the nucleus, you'll start to find this granular material. This is the chromatin. It consists of DNA-bound proteins. Hey guys, want to know something interesting about the cells? Do you want to know? I'ma tell you so. Yeah. Well, cells have the ability to split, and when they do, the chromatins condense into a form called chromosomes. Chromosomes are distinct, thread-like structures containing the genetic information that is passed from one generation of cells to the next. If you look to your left, you'll see them. Okay, enough of that. Now, we're gonna take a look at the nucleolus. I thought we already looked at that. No, dear. That was the nucleus. The nucleolus is a small dense region inside of the nucleus. The nucleus is the place where the ribosomes start to assembly. Yeah. And while we're on the subject of ribosomes, if you look to the right of you, you will see some of them. Okay, and ribosomes aid in the production of protein in the cell. There are also small particles made of RNA. There are two different kinds of ribosomes. You have free and attached. They're beautimous. Oh, they're beautimous. They help the cell do stuff. Yeah. Now, leaving the nucleus, you will immediately see the nuclear envelope. It is a structure in front of us that is a double membrane layer. This structure allows the material to move in and out of the nucleus. Any questions? Okay then, let's move on to the microtubules. The microtubules are hollow tubes of protein. They maintain the same shape and can also serve as tracks along which the organelles are moved. A smaller version of these are microfilaments, which you will see next. Next, we are going to move onto the endoplasmic reticulum. This is the organelle in which components of the cell membrane are assembled, and some proteins are modified. But there are two different kinds of ERs. For example, we honestly don't care. Well, that's too bad. Did I ever tell you guys how that kid lost his head? Yeah? No? Well, he was pushed by a tour guide. Anyway, moving on. There are two different parts to the endoplasmic reticulum, or ER. One of is the rough ER. The rough ER is involved in the synthesis of proteins and has its name because of the ribosomes that stud its surface. Newly made proteins move directly from these ribosomes into the rough ER, where they may be chemically modified. Its other half, the smooth ER, does not have ribosomes on the surface. The smooth ER contains collections of enzymes that perform specialized tasks and synthesis of lipids. Next is the Golgi apparatus. These are proteins produced by the rough ER, move into a stack of membranes. Now, as we pass, we will come across the vacuoles. Hey, that's our last name. Anyway, the vacuoles store materials such as water, salts, proteins, and carbohydrates. Vacuoles help make it possible for plants to hold up heavy structures. Now moving on to the chloroplasts. The chloroplasts are found in plants, and they use the energy from the sunlight to make energy-rich food molecules in a process known as photosynthesis. It also gives the plants their green color. Now we arrive to the mitochondria. The mitochondria are organelles that release energy from stored food molecules. Mitochondria uses energy from food to make high-energy compounds that the cell can use to power growth, development, and movement, also known as ATP. And that's right here. The vessels are the